All right, so let me talk to you guys about the two methods. The first one is simply to reprogram the cells from the mature state to the embryonic cell state to create this induced pluripotent stem cells. So a variation of this method actually as well is as present in some tissues is to reprogram them into the cells that without first passing them through the embryonic cell state. Such method has already been done to take skin cells from that are going around the heart and convert them into heart muscle cells. So you're taking cells from the same tissues, you're just changing the types of cells that they are. You don't have to actually pass through the embryonic cell state phase. And the second way to do it is to create new embryonic like cells from adult cells. So what you do here is you fuse an egg cell from a donor with cells from a person who needs these fresh cells with a technique known as somatic cell nuclear transfer. So it's called or therapeutic cloning. And so what you're doing here is you're taking an egg cell from a donor and fusing it with any fresh cell from the person. And so there's the risk of rejection this way is much, much lower. And so this can also help disabilities and age-related disease because these cells then can become any type of cells that you're looking for, right? These biochemical scientists can use biochemical cues to transform these um, cells into other cells, like neurons, myocytes for the heart, and so on. So these tools can be used in tissue engineering to build tissues and organs out of these um, cells that we obtain. So essentially, you can give a person you can give a person um, um, his you can turn his cells into an embryonic stem cell like ability so that they can turn their cells into any other cells that are needed that they need to treat age-related disease and disabilities and to produce as many cells as needed as well to do the job of tissue to perform the function. And so because the cells are from the same person, as I mentioned, there's no risk of immune rejection. And whereas cells and organs donated from another person come with a significant burden of aging, damage that accumulates while they're inside the donor, these new cells can be biologically young, free of defects that are present in the native cells, like mutations and the aging damage. And so these cells, because you're getting it from the same person, um, don't have those risks, don't have that risk of rejection and don't take that burden of aging. So that's pretty cool technique that we can use to deal with the loss of cells over time. So again, we can either reprogram them into the pluripotent stem cells or undergo the